Hi everyone, in this video we are going to talk about how we can calculate the oxidation number of organic compounds. Okay, specific atoms in organic compounds. In this case, we are calculating the oxidation number of the carbon circle in orange. Okay, so how we go about tackling such questions is by looking at the two atoms at a time, alright, and comparing their electronegativity values. So the one that's more electronegative will get a -1, right? Whereas the more electropositive or less electronegative atom will get a positive value, alright, +1. So let's look at this carbon here, okay, and we will realize that this carbon is bonded to another carbon here. So if we compare these two, I will actually give a value of 0 here and a 0 over here. Alright, so based on their comparison, I should get a 0 over here. So let me erase this other 0 because we are not looking at that 0 right now. Now let's compare this carbon here to this oxygen. Alright, if we compare the both of them, the oxygen is more electronegative, so it should get the negative and this should get the positive. But because it has a double bond here, right, it means that it has actually lost right, 2 electrons to oxygen. So oxygen will get a -2 charge while this will get +2. Okay, because there are 2 bonds here. Then if we compare this last carbon with this last oxygen here, this oxygen is more electronegative, so it gets a -1. They are only sharing a pair of electrons, so this will get +1. So altogether, the carbon atom will be +3. So if we were to consider this other oxygen atom, right, when it already has a -1, so if you compare it to the hydrogen here, hydrogen is less electronegative, so it gets a +1. This gets -1, so you get a total of -2. Okay, so let's take a look at the second example. In the second example, we have to include the other 2 hydrogen atoms that have been omitted. So once again, this carbon versus this carbon, both are the same, so I will give 0 to both of them. Okay, this carbon versus this hydrogen. Hydrogen is obviously less electronegative, so it gets +1. This carbon gets another +1. If I were to compare it against this hydrogen, okay, you will get you will get -1, -1, +1. Then now I compare this carbon with this oxygen here. This is more electronegative, so this gets the -1, this gets +1. So altogether, you will get -1. Okay, let's move on to the third example. Okay, so once again, if we look at the bond on the left, carbon versus carbon, this will get a 0. Now the second one, this carbon versus this carbon, once again, is another 0. Then compared to this oxygen, 2 bonds here, so it is +2. Alright, so if I sum them up, the oxidation state of that carbon is +2. In our last example, compared to this carbon, this gets a 0. Compared to this hydrogen, since carbon is more electronegative, it gets a -1. Compared to this oxygen here, we get a -2 because of the double bond. Sorry, +2. So altogether, we end up with +1. Okay, so if you realized, if we oxidize an alcohol, it will go from -1. Okay, in this case, it's a primary alcohol, so we can oxidize it to an aldehyde, which is +1. Okay, and if we oxidize it even further, it will become a carboxylic acid. In this case, it will become +3. So as you can see, this method allows us to calculate the oxidation state of this carbon that is circled in orange, right? And this shows us how we can oxidize it and increase the oxidation number along the way. Alright, so this is how you can go about calculating the oxidation number of organic compounds. So if we were to extend it to inorganic compounds such as hydrogen peroxide, okay, often we give hydrogen peroxide the value of -1. So let's look at this together and see how we can get the value of -1. So if we were to look at this oxygen atom itself, if we consider this oxygen with this hydrogen, this gets a +1, this gets a -1. If you compare these two oxygens, you'll notice that they have the same electronegativity values, so you'll get a 0 here. So if you add these two values together, you will get -1. So that is how we can apply the same method to get -1 for the oxygen atom in hydrogen peroxide.